learners. I am Sir Tomas C. Benitez Jr. of San Rosario Integrated School, and I'm your teacher for this hour. Today, you're going to join me in our discussion for Mathematics 9, Quarter 2, Week 6. Before we begin, be sure that you have your pen, paper, and your module with you. Our topic for today is Simplifying Radicals, written by Teacher Berlin B. Cabal. How many kinds of numbers can you identify? If you can name more than 5 kinds, then that's good. Radicals are one of the different kinds of numbers. You have learned about these numbers in Quarter 2, Week 4, and Week 5. Radicals have many applications in real life, like solving for the speed of a car based on the length of the skid marks, and finding the velocity of a falling object. These are also applied in the fields of engineering, architecture, and carpentry. The learning competency covered in this lesson is simplifying radical expressions using the laws of radicals. The objectives of these lessons are: state the laws of radicals, identify the laws of radicals applied in a given statement, and simplify radical expressions using the laws of radicals. Before we proceed with our lesson, let us have a review on laws of radicals. Assume that when n is an even and a is greater than 0. Law number 1. The quantity nth root of a raised to n is equal to nth root of a raised to n equals to a. Law number 2. The nth root of a and b can be expressed in a product of nth root of a and nth root of b. Law number 3. Nth root of a over b can be expressed in a quotient of nth root of a all over nth root of b for as long b is greater than 0. And law number 4, mth root of nth root of a is equal to the product of m and n roots of a or nth root of mth root of a. Identify the laws of radicals applied in simplifying each of the following. Time is up! These are the answers. Number 1, law number 4. Number 2, law number 3. Number 3, law number 1. Number 4, law number 2. And number 5, law number 4. Did you get all the correct answers? Very good! It seems you're already familiar with the laws of radicals. Let us now study how to simplify radicals. How do we remove the perfect nth powers? For radicand, which is not a perfect nth power, break down its factors into perfect and non-perfect nth powers and apply law number 2. Let us study the examples. Simplify square root of 18. Notice that 18 is not a perfect square, so we have to factor out. Based on our solution, square root of 18 is equal to the square root of the factors such as 9 and 2. Then we can separate the 2, or we can break down. Square root of 9 multiplied by square root of 2. Square root of 9 is equal to 3. Therefore, square root of 18 is equal to 3 square root of 2. Another, simplify 5th root of 96. So again, we need to factor out 96. So 5th root of 96 is equal to the 5th root of 32 and 3. We can now break down the 2. So we have 5th root of 32 times 5th root of 3. Fifth root of 32 can be expressed as fifth root of 2 raised to the 5 power multiplied by fifth root of 3. Therefore, fifth root of 96 is equal to 2 fifth root of 3. Let's move on. Number 3. Simplify the 8th root of b raised to 11 power. So, the solution, 8th root of b raised to 11 can be expressed as 8th root of b raised to the 8th power times b cubed. Then break it down. We have 8th root of b to the 8th power multiplied by 8th root of b cubed. Therefore, 8th root of b raised to 11 power is equal to b 8th root of b cubed. How about number 4? Simplify the 4th root of x to the 6th power and y to the 9th power. So we have to factor out x to the 6th power and y to the 9th power. So based on our solution, 4th root of x to the 6th power times y to the 9th power can be expressed as 4th root of x to the 4th power multiplied by x squared, y to the 8th power multiplied by y. So the new expressions will be 4th root of x to the 4th power y to the 8th power multiplied by 4th root of x squared y. The new expression can be 4th root of x to the 4th power times the quantity y squared raised to 2 multiplied by 4th root of x squared y. So the new expression will be 4th root of the quantity xy squared raised to 4 multiplied by 4th root of x squared y, removing the perfect n power. So we have 4th root of x to the 6th power y raised to the 9th power is equal to y squared x 4th root of x squared y. Number 5. Simplify the cube root of 40x to the 10th power y raised to 7. So we can now factor the radicand. Based on the solution, cube root of 40x to the 10th power y to the 7th power can be expressed into cube root of the product of 8 times 5 x to the 9th power x y to the 6th power and y. Then break it down. Separate the perfect n powers and non-perfect power. So the new expression will be the quantity cube root of 2 cubed x to the 9th power y to the 6th power multiplied by cube root of 5xy. So the new expression will be the quantity cube root of 2x cubed y squared raised to 3 multiplied by cube root of 5xy. Therefore, the simplest form is 2x cubed y squared cube root of 5xy. Moving on, reducing the index to the lowest possible order. Now, if the exponent of the radicand is less than the index but has the same factor as the index, then reduce the lowest term and apply law number 4. Let's study the illustrative examples. Number 1, simplify the 8th root of 16. So in this case, we have two possible ways on how to simplify this. Let us consider the first solution. 8th root of 16 can be expressed as 8th root of 2 raised to the 4th power. So from the new equation, we have the square root of 4th root of 2 to the 4th power. So we factor out the index such as 2 and 4 so that we can cancel the index 4 and the exponent of 2 raised to 4, which is 4. Therefore, the 8th root of 16 is equal to square root of 2. Another way of simplifying this is in the solution 2. So we can express this one into exponential form. So we have 8 root of 16 is equal to 8 root of 2 raised to 4 can be expressed in exponential form, wherein it is equivalent to 2 raised to 4 over 8. Knowing that 4 over 8 can be expressed into lowest term, so we have 2 raised to 1 half. We can now express this into radical expression, such as square root of 2 raised to 1, or to make it short, that is equivalent to square root of 2. How about example number 2? Simplify the 16th root of 81x to the 4th power. So let us consider solution number 1. So 16 root of 81x to the 4th power can be expressed as 16 root of 3 raised to the 4th power and x to the 4th power. Notice that the exponents of the radicand are 4. So we have to factor out the index, or in one of the factors is 4. So we have the 4th root of 4 to the 4th root of the quantity 3x raised to 4, cancelling the exponent 4 and the index 4. So therefore, we have 4th root of 3x. On the other hand, 16th root of 81x to the 4th power can be expressed as 16th root of 3 raised to the 4th power x to the 4th power, expressed in exponential form. We have the quantity 3x raised to 4 over 16. So 4 over 16 can be reduced in simplest form, wherein 4 and 16 are divisible by 4. Therefore, 3x raised to 1/4. Now we can now express in radical, that is 4th root of 3x. Simplify the 18th root of 27a to the 6th power b raised to 9. Let's take a look at solution 1. So this can be expressed as 18th root of 3 cubed, a to the 6th power, and b raised to 9. Notice that the radicand has common factor 3. Therefore, we can factor out the index such as 18 by 6 and 3. So, the 6th root of cube root of 3 cubed times the quantity a squared raised to 3 times the quantity b cubed raised to 3. Cancelling the exponent 3 and the index 3. So we have 6th root of 3a squared b cubed. How about solution 2? So again, express the radical form into exponential. So we have the quantity 3a cubed, a to the 6th power, and b raised to 9 raised to 1 over 18. Applying distributive property, we have 3 raised to 3 over 18, a raised to 6 over 18, and b raised to 9 over 18. So take the lowest term of these exponents, wherein the denominator is 6. So we have 3 raised to 1 over 6, a raised to 2 over 6, and b raised to 3 over 6. Therefore, the 18th root of 27a to the 6th power b raised to 9 is equal to the 6th root of 3a squared b cubed. How about rationalizing denominator? If a radical expression contains a radical in the denominator, or the radicand contains a fraction, then rationalizing of the denominator is required. Rationalizing of denominator is a process of eliminating the radical in the denominator. Let's take a look on example number 1. Simplify 6 over square root of 7. Notice that the denominator is a radical. So we have to remove the radical in the denominator. So based on the solution, we have 6 over square root of 7 can be expressed as 6 all over square root of 7 multiplied by 1. Applying the identity property of multiplication. Then, we have to find or determine the equivalent expression of 1 such that when the denominators are multiplied, the product is a perfect square. So therefore, 6 over square root of 7 multiplied by square root of 7 all over square root of 7, we have the product 6 square root of 7 all over square root of 49. So to simplify, we have 6 square root of 7 all over 7. Okay, moving on, example 2. Simplify the square root of 1 over 3. So, based on the solution, square root of 1 over 3 can be expressed as the quotient of square root of 1 all over square root of 3. Then, applying the identity property of multiplication. So, we have square root of 1 all over square root of 3 multiplied by 1. Then, afterwards, again, identify the equivalent expression of 1 such that when the denominator are multiplied, the product is a perfect square. So, from the expression square root of 1 all over square root of 3 multiplied by square root of 3 all over square root of 3, we have square root of 3 all over square root of 9. So, the simplest form is equal to the square root of 3 all over 9. Next, simplify the cube root of 3 all over cube root of 2. Okay? Cube root of 3 all over cube root of 2 can be expressed as cube root of 3 all over cube root of 2 times 1. Determine the equivalent expression of 1 such that when the denominators are multiplied, the product is a perfect cube. That's why we have cube root of 3 all over cube root of 2 multiplied by cube root of 2 raised to 2 all over cube root of 2 raised to 2. The new expression will be cube root of the product of 3 times the quantity 2 raised to 2 all over the cube root of 2 cube. So the expression will be cube root of 3 times 4 all over cube root of 2 cube. Therefore, cube root of 12 all over 2. Next, simplify cube root of 2 over 5b. Okay? Cube root of 2 over 5b can be expressed into cube root of 2 all over cube root of 5b times 1. Applying the identity property of multiplication. Cube root of 2 all over cube root of 5b then multiplied by cube root of 5 squared b squared all over cube root of 5 squared b squared. So we have the new expression cube root of 2 times the quantity 5 raised to 2 times b squared all over cube root of 5 cube b cube. So the new expression will be cube root of 2 times 25 times b squared all over cube root of the quantity 5b raised to 3. Therefore, the simplest form is cube root of 50b squared all over 5b. Let's move on to sample 5. Simplify 20 all over 4th root of 2x cubed y squared. So this can be expressed as 20 all over 4th root of 2x cubed y squared multiplied by 1. Therefore, the new expression will be 4th root of 2 cubed x y squared all over 4th root of 2 to the 4th power x to the 4th and y to the 4th. To simplify, we have 20 4th root of 8xy squared all over 4th root of the quantity 2xy raised to the 4th power. Simplifying the denominator, we have 20 4th root of xy squared all over 2xy. Notice that 20 and 2 are divisible by 2. Therefore, the simplest form is equal to 10 4th root of xy squared x all over xy. Okay, number 6. Simplify 1 over 2 plus square root of 5. Okay, how many terms do we have in the denominator? Very good. The denominator contains a binomial term. Then, how do we rationalize the denominator containing binomial term? Okay, to rationalize the denominator, get the conjugate of the binomial. Binomial is a form of the sum of a and square root of b and a minus square root of b are called conjugates, where a and b are rational numbers. The conjugate is where we change the sign of the middle of the terms. Like for example, the quantity 3x plus 1, its conjugate is 3x minus 1. Here are some examples of pairs of conjugates. The sum of 4 and square root of 3 and 4 minus square root of 3, 7 minus square root of 10 and 7 plus square root of 10, square root of 3 plus 12 and square root of 3 minus 12. So let's move on solving number 6 or simplifying number 6. So based on the solution, 1 over the sum of 2 and square root of 5 can be expressed as 1 all over the sum of 2 and square root of 5 multiplied by 1. So identify the expression of 1 using the conjugate of the denominator. So which means we have 1 over 2 plus 5 multiplied by 2 minus square root of 5 all over 2 square root of 5. So we have 2 minus square root of 5 all over 4 minus 2 square root of 5 plus 2 square root of 5 plus square root of 25. So applying the FOIL method to obtain this product. So we have 2 minus square root of 5 all over 4 minus 5. So we have the new expression 2 minus square root of 5 all over negative 1. So when dividing negative 1, we have negative 2 plus square root of 5. And last, simplify 4 all over square root of 6 minus 2. So we can express this as 4 all over square root of 6 minus 2 times 1. Again, determine the equivalent of 1 using the conjugate of the denominator. So we have 4 all over square root of 6 minus 2 multiplied by square root of 6 plus 2 all over square root of 6 plus 2. So we have the product such as 4 square root of 6 plus 4 times 2 all over square root of 36 plus 2 square root of 6 minus 2 square root of 6 plus 4. So cancel positive 2 square root of 6 and negative 2 square root of 6. So we have 4 square root of 6 plus 8 all over 6 minus 4. So we need to get the common factor of 4 square root of 6 plus 8. So we have 2 times the quantity, 2 square root of 6 plus 4 all over 2. So cancel 2 and 2. Therefore, the simplest form is equal to 2 square root of 6 plus 4. Okay. Now, how do we know that a radical expression is expressed in simplest form? Remember that a radical expression is in the simplest form if number 1, no prime factor of radical has an exponent equal to or greater than the index. Number 2, no radicand is a fraction. And number 3, no radicand is in the denominator. By this time, you should be able to simplify radical expressions using the laws of radicals. Now, it is time for you to practice what have you learned by going over and answering your GLA in Mathematics 9, Quarter 2, Week 6. Learning math is easy. Again, this is Teacher Tom of Santa Rosa Integrated School. Have fun and answering your module.